So in the previous video we have seen how to do the circular convolution using concentric circle method. Now in this video we are going to learn how to do the circular convolution using matrix multiplication method. So when we have done the convolution, we have changed the second signal. If you remember, we have changed the outer circle, we have maintained the inner circle constant. In the same way, during the matrix multiplication also, what we'll do is, we'll take a matrix of n by n rows, n columns, and we'll take x of n. Okay, so the product between these two gives us the values. Here x of n value is 1, minus 1, minus 2, 3, minus 1, 1. Okay, these are that means this is one column, 6 rows. This is 1 by 6 matrix. 6 rows, 1 column. Sorry, 6 rows, 1 column. It is 6 rows, 6 columns. It should be. So first, this is the case when we consider h of n, right? Now we go on shifting. Now here 0, we shift this one up. 0, 1, 2, 3, 0, 0. We're going to shift this until the original sequence comes 0, 0. Now again this here 1, 2, 3, 0. Again this is here 0, 0, 0, 1, 2, 3. Again, so 3, 0, 0, 0, 1, 2. Again 3, 2, 0, 0, 0, 1. Right? 3, 2. This is column 3 zeros, 1 0, 3 0. Okay, sorry. Here it is 2, here it is 3. Now see, if I do shift one more time, then the same sequence will be repeating. So the number of shiftings are n shiftings. How many elements we have, samples we have is 6. So n shiftings are enough. So 6 shiftings, 6 rows and 6 columns, and 6 rows and 1 column. We try to multiply first row with first column, first row with this column, second row with this column, third row, fourth row. Then we get the values as 1 into 1, 1, 1, 3 zeros, so definitely 3 zeros, 3 into minus 1, minus 3, plus 2 into 1, 2. This gives you 0. So the first term is 0, y of 0 is 0. As there are 6 samples, from y of 0 to y of 5, we get the convolution values. Similarly, 2, 1, 0, 0, 0, 3. 2 into 1, 2. 1 into minus 1, minus 1. 3 zeros, 3 zeros. 3 into 1, 1, 3. 3 plus 2 minus 1 is 4. Similarly, get the other values. Right? This is how we do the convolution, circular convolution using matrix multiplication method. Right? We do not change x of n values, we keep them as it is, but we are going to shift h of n for n times. That means how many samples we have, that many times we need to shift the sample and multiply this x of n with h of n, we get y of n. As you know, I already mentioned, convolution is sum of products. We are doing the product and we are adding them so that we get the convolution sum. Right? This is how we do circular convolution using matrix multiplication. Now, the next two methods we get are overlap save method and overlap add method. Right. Now, why we are going for overlap save method and overlap add method? First thing is, whenever we consider as input sequence x of n, okay, it might have many values, right? Considering from x of 0, it might have x of 15, x of 16, and h of n, whereas h of n has some x of 8 values, starting from x of 0. Okay. So whenever the input sequence is becoming more, and as we are dealing with discrete signals, digital signals, for a microprocessor, okay, for a microprocessor, there will be some memory limitation. It can take only few values, and it can able to perform the digital operations. For that thing, what we'll do is, from x of 0 to x of 15, okay, with the sequence, we will divide them. We will divide them into 3 or 4 blocks, and we will try to compute them individually. Compute individually. Block 1, block 2, block 3. Compute individually and try to append them at one place. After computing, try to append them. Then we get the convolution y of n at one place. This is how these two methods are: overlap save method and overlap add method. First, we'll deal with overlap save method.